Good morning, everybody. Welcome to the second segment on analysis of series magnetic circuit. In this segment, we will be seeing some numericals where the effect of leakage flux is neglected. These are some of the tips that will help you in solving numericals. So, whenever you get a problem, first thing we have to do is to identify the nature of magnetic circuit. That is, whether it is a series magnetic circuit or a parallel magnetic circuit. Next, write down the given parameters using the standard notations in SI unit. Step 3 is check whether the effect of leakage flux is neglected in the question. For a series magnetic circuit with effect of leakage flux neglected, the following equations will hold true. First of all, the flux will be same. That is, flux in core will be equal to flux in air gap. Regarding the total MMF will be equal to the sum of MMF. That is, total MMF will be equal to MMF of part 1 plus MMF of part 2 plus etc. Total MMF, that is Ni, where N is the number of turns and I is the current through the coil. That will be equal to phi S1 plus phi S2 plus etc. Where phi is your flux and S1, S2, etc. they are the reluctance of each part. Effective reluctance S will be equal to S1 plus S2 plus etc. So whenever you do a problem, please keep following steps in mind so it will be easy to solve the magnetic circuits. Now let's move on to the numerical section. Please go through this question. So in this question we can see that I'm having an iron ring and it is wound with a coil having 500 turns and a resistance 4 ohm. So we can draw the figure like this. A coil is wound on a ring and the coil is having some turns and also a resistance. So writing down the parameters, number of turns, that is capital N, is equal to 500. Resistance, that is capital R, is equal to 4 ohm. And also it is given that the mean diameter of the ring, mean diameter, that means this length. This is your mean diameter and it is given in the question as mean diameter, that is your capital D, is equal to 0.25 meter. The next parameter it is given is the uniform cross-sectional area of the ring. So cross-sectional area that is marked in the figure as small letter a. And it is given as A equal to 700 mm square. So converting it into SI unit, we will be getting it as 700 into 10 raised to minus 6 meter square. Also it is given that the coil is supplied with a voltage, that is V equal to 6 volt, and the relative permeability of the ring, that is mu R equal to 550. So these are the given parameters. So by looking into the figure, we can see that the flux is only having one path to flow. So this circuit is a series magnetic circuit. Hence, for a series magnetic circuit, we can say that the total MMF will be equal to sum of MMF. But here there is only one material, that is your iron ring. Hence we can write total MMF will be equal to MMF of iron path. So substituting for total MMF and MMF of iron path, we will be get Ni equal to 5 into S, where N is the number of turns, I is the current, phi is the flux, and S is the reluctance of iron path. In the question, we have to find the flux in the ring. So finding the flux, we have to find total MMF Ni, as well as we need to calculate the reluctance S. Now let's see how we can find these parameters. So first thing we need to find out is the current through the coil. So current through the coil, that is equal to voltage across the coil by resistance in the coil. So that is I equal to 6 by 4, which is equal to 1.5 amperes. Now we can find the total MMF as total MMF is equal to N into I, that is 500 into 1.5, and it will be obtained as 750 ampere turns. Now the reluctance of the iron, that is S, is equal to L by mu 0 mu R into A. Mu 0, that is the permeability of free space. It is a known value. Mu R, it is given in the question as 550. A is the area of cross section of ring, that is given in the question as 700 into 10 raised to minus 6 meters square. So we need to find L. L is the main length of the flux path. To find that, the diameter of the ring is given. So using that, we can find the value of L. So the mean length of the flux path L is actually the perimeter of the ring. So L is equal to pi into D, that is pi into 0.25. So that is equal to 0.7854 meter. So substituting for parameters, we will be getting it as reluctance. S is equal to 1.6 into 10 raised to 6 ampere turns per Weber. Now the total flux in the ring, phi is equal to Ni by S. Substituting for Ni as well as S, we will be getting total flux as 0.462 milliweber. Please go through the second question now. So in this question, we can see that we are having an iron ring but with an air gap of 1 mm. So I can draw the circuit like this. An iron ring with an air gap of 1 mm, and I am denoting the air gap here as G. First we can write down the given parameters. Here it is given the mean length of the ring is 50 centimeter. So here the mean length, that is denoted in the figure as small letter L. So mean length means it will also include the length of air gap. So that is given as 50 centimeters, converting it into the SI unit, that is 50 into 10 raised to minus 2 meter. And the air gap length that is given as 1 mm, that is Lg, that is equal to 1 into 10 raised to minus 3 meter. And the coil, it is having 200 turns. So N is equal to 200. Then the relative permeability of the ring, that is mu r, that is given as 300. And the current through the coil is 1 ampere. Then it is asked that take the permeability of air as 4 pi into 10 raised to minus 7. So in this question the mu 0 value is given, that is 4 pi into 10 raised to minus 7 meters. So here we have to find the flux density. So by going through the figure we can see that here the flux is having only one path to flow. So this is a series magnetic circuit. Since in the question nothing regarding the leakage factor is mentioned, so we can neglect the leakage flux. So for a series magnetic circuit with leakage flux neglected, the total MMF will be equal to sum of MMF. Here we are having an iron ring as well as an air gap. So we can write total MMF will be equal to MMF of iron path plus MMF of air gap. Substituting, we will be getting it as total MMF, that is Ni, will be equal to phi into Si plus phi into St. Flux is same and that is equal to phi, and Si, that is the reluctance of the iron ring, and Sg, that is reluctance of the air gap. So here I need to find out the flux density. So I am substituting flux in terms of flux density. So flux density is equal to phi by A. So flux can be written as flux density into A, where A is the area of cross section. Because in the question area of cross section is not given. So we need to adopt some ways to neglect this term. So instead of phi, I am substituting it as B into A. And Si is equal to Li by mu 0 mu r into A. Plus, instead of phi, again we are substituting it as B into A. And Sd is equal to Lg by mu 0 A. In the case of an air gap or an air material, the relative permeability value is 1. So that is why in the denominator I am only having mu 0 A. So area of cross section A and A will get cancelled, and taking B common we will be getting it as Ni will be equal to B into Li by mu 0 mu r plus Lg by mu 0. The value of N is given in the question. I is also there in the question. B we need to find out. Then Li value, that we need to find out also. Here L is given and Lg is given. From that we can find the Li value. Mu 0 is in the question. Mu r is also in the question. Lg is in the question. So all the other parameters is directly given in the question. So we can find the flux density by substitution. So total MMF, first we can find that. So total MMF is equal to N into I, that is 200 into 1, that is equal to 200 ampere turns. Then we need to find out the length of the iron path, Li. So here in the question mean length is given, that is L is given. So length of the iron path is mean length minus the length of air gap. So that is Li equal to L minus Lg. So it will be obtained as 0.499 meter. So substituting in the above equation, we will be getting it as 200 is equal to B into 0.499 by 4 pi into 10 raised to minus 7 into 300 plus 1 into 10 raised to minus 3 divided by 4 pi into 10 raised to minus 7. So flux density B will be equal to 200 divided by 2119.413. The flux density, that is equal to 0.0944 Weber per meter square. Flux density is having two units. Either we can write Weber per meter square or Tesla. Hope you are clear with the previous two problems. Now let's move on to the third question. Please read this question. So in this question, it is said that it is a closed magnetic circuit, but it is having two different parts. Both of them are made of cast steel, but have different area of cross section as well as different length. One part is a 6 cm long and the another one is 2 cm long, and one is having an area of cross section 1 cm square and the second one is having an area of cross section 0.5 cm squares. So we can draw the figure like this. A closed circuit with two parts and having different length and different area of cross section. So I'm denoting part 1 as the one which is having a length of 2 into 10 raised to minus 2 meter and an area of cross section 0.5 into 10 raised to minus 4 meter square. And the second part is having a length L2 is equal to 6 into 10 raised to minus 2 meter and an area of cross section 1 into 10 raised to minus 4 meter square. It is said in the question that a coil having 200 turns is wound on 6 cm long part. That is, in the 6 cm long part, I place a coil where n equal to 200 and this is carrying a current of 0.4 amperes. So this will be a figure. In this question, we have to find the flux density in 2 cm path. That is the flux density in part A. The relative permeability of the material, that is the cast steel, is also given. So now let's try the given parameters. L1 is equal to 2 into 10 raised to minus 2. A1 is equal to 0.5 into 10 raised to minus 4. L2 is equal to 6 into 10 raised to minus 2. A2 equal to 1 into 10 raised to minus 4. Then number of turns of the coil, that is N equal to 200. Current through the coil, that is I equal to 0.4 ampere and mu R is equal to 750. We need to find the flux density, that is B, in part 1, that is in the 2 cm long part. So from the figure it is clear that the flux is only having a single path to flow and each part is connected in series. So this is a series magnetic circuit. So since there are two materials, two parts are there, we can write total MMF, that will be equal to MMF of part 1 plus MMF of part 2. Substituting for, we will be getting it as Ni equal to 5 into S1 plus 5 into S2. Since flux is same, we can write that is equal to 5 into S1 plus S2. So in the question, number of turns is given as well as the current is given. So we can find the total MMF, that is Ni equal to 200 into 0.4, that is equal to 80 ampere turns. Okay, so next we need to find the reluctance in each part. So reluctance in first part, All the parameters are given directly because finally we need to find the flux density. To find flux density, we need to first find the flux. For that, we need the values of S1 and S2. So substituting in the equation for S1, we will be getting the value of S1 as 4.24 into 10 raised to 6 ampere turns per Weber. Similarly, reluctance of the second part, S2, that can be obtained as L2 by mu 0 mu r into A2. All the values are given directly in the question. You just need to substitute it. So, substituting in the above equation, that is Ni equal to 5 into S1 plus S2, we will be getting Ni, that is 80, is equal to 5 into 4.24 into 10 raised to 6 plus 6.36 into 10 raised to 6. So that is, from that we will be getting total flux as 5 is equal to 80 by 10.6 into 10 raised to 6. So total flux is 7.54 into 10 raised to minus 5 Weber. But in the question it is asked to find the flux density in part 1. So flux density is flux by area of cross section. So flux density in 2 cm path will be equal to flux phi by A1. That is area of cross section of the 2 cm part. So we will be getting it as 1.509 Weber per meter square. Please go through the fourth question. In this question it is said that there is an iron ring with an air gap of 1.5 mm and the mean diameter of the ring as well as the diameter of circular cross section is given, and this ring is wound with a coil having 750 turns and carrying a current of 2.1 ampere. So we can draw the circuit like this. A circular ring, mean diameter 25 into 10 raised to minus 2 meters. Then diameter of the cross section, that is 3 into 10 raised to minus 2 meter. Air gap length, that is equal to 1.5 into 10 raised to minus 3 meter. So write down the given parameters. Mean dia, that is capital D, equal to 25 into 10 raised to minus 2 meter. Then small letter d, that is the diameter of the cross section, that is given as 3 into 10 raised to minus 2 meter. Then length of the air gap, that is Lg, equal to 1.5 into 10 raised to minus 3 meter. The number of turns in the coil, that is Na, equal to 750. Then current through the coil, that is I, equal to 2.1 ampere. So in the question we are asked to find total MMF, that is Ni, as well as flux density in the air gap, that is flux density means B. We have to find the flux density in the air gap. Then total magnetic flux, that is phi. Then relative permeability of the iron ring, that is mu r. Okay, so these are the parameters that we have to find, and in the question it is given that iron part takes about 35% of total magnetomotive force, that is MMF of the iron path is 35% of total MMF. So from the figure it is clear that there is only one path for flux. So this is a series magnetic circuit. Since the leakage factor is not given in the question, we can neglect leakage flux. Hence, the equation for total MMF will be total MMF is equal to MMF of iron ring plus MMF of air gap. Since there is only two material, one is an iron ring and the other one is air gap. So substituting, we will be getting it as total MMF, that is Ni, equal to MMF of iron ring, that is phi into Si plus mmf of air gap, that is phi into Sg. So first we can find the total mmf, that is Ni equal to 750 into 2.1, that is 1575 ampere turns. So in the question it is given that the iron part takes about 35% of total mmf. So we can write mmf of iron ring, that's actually phi into SI, that will be equal to 35 by 100 into total mmf. Substituting for total mmf, we will be getting it as 551.25 ampere turns. So since we know the total mmf as well as mmf of iron ring, we can find the mmf of air gap, that is phi into Sg is equal to total mmf minus mmf of iron ring, that is equal to 1023.75 ampere turns. So in the question we need to find the total flux. So from the mmf of air gap we know that phi Sg is equal to 1023.75. So if you are finding the Sg value, that is the reluctance of the air gap, we will be able to find flux. So reluctance of the air gap Sg is equal to Lg by mu 0 A. But in the question the area of cross section, that is not directly given. But in the question it is given that diameter of the cross section, that is 3 into 10 raised to minus 2 meter. We know that the cross section is circular. So area of the cross section A is equal to pi r square, that is equal to pi into d by 2 the whole square, and can get it as 0.7068 into 10 raised to minus 3 meter square. So now substituting for area of cross section, we will be getting it as reluctance Sg is equal to 1.688 into 10 raised to 6. So by substituting in mmf of air gap's equation, we will be getting flux in air gap as 1023.75 divided by 1.688 into 10 raised to 6, that is 0.606 milliweber. Hence the flux density in the air gap, that is equal to flux by area of cross section, that is 0.606 into 10 raised to minus 3 divided by 0.7068 into 10 raised to minus 3, that is equal to 0.8576 Weber per meter square, or we can write it as 0.8576 Tesla. Now next parameter that we have to find is mu r, relative permeability of the iron material. The value of mu r can only be found out from the reluctance value. So the reluctance of the iron ring Si can be written as mmf of the iron ring divided by flux. So from that value we will be getting reluctance Si is equal to 9.09 into 10 raised to 5. So we know that Si is equal to Li by mu 0 mu r into A. Area of cross section we know, mu 0 value is already a known value. Then Li value, that is the mean length of the flux path, that we can find out since the mean diameter of the ring is given. So the mean length of the iron path, that is Li, will be equal to length of the ring minus length of air gap. So length of the ring, that means the perimeter of the ring, that is equal to pi into d minus Lg. So mean length of iron path, that will be obtained as Li equal to 0.7839 meters. So substituting for Li in this equation, and we can find the mu r as mu r is equal to Li by mu 0 Si into A. and we will be getting relative permeability as 969.88 or approximately 970. So with this we come to the end of the second session. In the third section we can see some numericals where the effect of leakage flux is taken into account. Thank you.